Hello folks, this is 2020 October November paper 1-2 and the question number is 23. This question is concerned with the chapter waves. Chapter waves, or we can even say periodic motion also. It says that when sound travels through air, the air particles vibrate. So air particle vibrate like this. When sound goes from here to here, the particle vibrate around the mean position like this. A graph of displacement, again time for the single particle is shown, yes, like this. So initially displacement was maximum, then 0, then negative maximum here, 0, positive maximum, and so on. Which graph shows how the kinetic energy of the air particles varies with time? So we have to search for that graph which shows the correct variation of KE with time. So what we have is, we have a particle like this. It displaces up to this position and back up to this position, and again like this. It goes like this. So here, before returning back, it has to come to rest. So if it is rest, K is 0 here. So when x is maximum, K should be 0. Similarly here also, when it is maximum displacement here, negative, it has to come to rest. So K should be 0. So here also K should be 0. So K should be 0 when the displacement is positive max or negative max. Let's see. So here we have got it is negative max here, displacement. So during that time, K should be equal to 0. Should be equal to 0. So here it is not 0, doesn't disqualify. Not 0, disqualify, doesn't disqualify. Here 0 and 0, it has to disqualify. It has to qualify. Then at that time, displacement is 0. So here it will be traveling with maximum speed. Maximum speed because of the force here. So here the speed will be maximum, K should be max. So here, that means here, somewhere around here, K should be max. And here it is not max, it is max. So this should qualify, this should disqualify. Here, displacement max. So that means the K should be again be 0. So this position means here, somewhere here, K is maximum, disqualify. But here K is 0, it qualifies. Again, in this position, displacement 0, K should be max. So 0, K should be max. K is not max. K is max, it qualifies. So that's why going through this way, going through this pattern, we can say that this choice number D should be the correct choice and all others are incorrect choices. Now we can use this, we can solve this by the help of problems, by the help of equations, actually, equations of simple harmonic motion. But that is not in the scope of AS, so that's why I'm not using the equations. Otherwise, had we been using the equation, it could have been much more easier. It could have been much more easier. So the equation would be somewhat like this. KE will be equal to 1 by 2 mv square, and in simple harmonic motion or periodic motion, the value of V will be equal to minus omega x naught square minus x square. This is amplitude displacement. So V square should be equal to, this is omega square. Sorry, this is let me do it like this. It is root here. So it should be omega square, then x naught square minus x square. So if I substitute here, the value of K should be equal to 1 by 2 m omega square x naught square minus x square. So when x equal to 0, when displacement is equal to 0, K equal to maximum. Displacement is equal to 0, K should be max. When it is equal to x naught, the amplitude maximum, then K equal to 0. So equation would have helped it much better, much clearer picture would have been given. But in AS we don't use that. So when you are already in A2 or when you reach A2, you can try this technique to solve this question once again.